Hello and welcome to Creating, Updating, and Deleting Data from an API, part of the Building APIs with ASP.NET Core course. In this module, we'll walk through the processes and helpers in ASP.NET Core so you can build APIs that do more than just return data. My name is Kevin Griffin. I'm an independent software consultant and 10-time Microsoft MVP focused in ASP.NET development and deploying solutions to Microsoft Azure. It is my pleasure to teach you how to build APIs with ASP.NET Core. In this module, we're going to discuss data manipulation, or how to build APIs that create, update, and delete data within a system. We'll cover model binding and model validation to help you pull the correct data from incoming requests without much effort. In this section, we'll cover what data manipulation is and how it works with APIs, and how these approaches translate into actions you're building within ASP.NET Core. In previous modules, we discussed HTTP verbs and the role they serve in describing the intent of a request. And in the past, we covered HTTP GET requests and how we can efficiently return data to a client. But that is only a fraction of the possibilities with our APIs. What happens when we want to create, update, or delete data within our system? That's where the verbs post, put, patch, and delete come into play. Let's review what these verbs are used for. HTTP POST is typically used to create or insert data into a system. Our expectation with this request is that it will contain all the information necessary to create the entity. HTTP PUT can be used several different ways. Ideally, when you call HTTP PUT, your intention is to replace an entity within your application. For example, if I call this method with an ID of 5 and some product information, my intention is for the product with the ID of 5 to be fully replaced within the database. I've also seen many APIs that selectively update aspects of an entity using a put as well. There's no penalty for doing that. However, if you're replacing or updating individual parts of an entity, HTTP patch is a more ideal verb to use. As with put, it's expecting the ID of the entity that's being updated and the details for that entity. There are no built-in helpers that determine what on the entity needs updating, so you have to write that logic yourself. This is the primary reason why put and patch are sometimes done as just put calls. And finally, HTTP delete removes an entity from a data store. All you have to do here is provide the ID of the resource you want to delete. In this section, we're going to cover model binding within ASP.NET Core and how you can use it to pull data automatically from incoming requests. We use the term model binding to describe the action of translating data from an incoming request to an object we can actually use. A web development in general would be pretty tedious if we had to do all the request processing ourselves. Without model binding, you'd have to read the body of the incoming request and then determine its format, and then extract the content of the body to match whichever type you needed within your code. Nowadays, it's most common for HTTP requests to use JSON as the mechanism for sending data. However, there are still some clients and systems that want to communicate via XML. And lucky for you, ASP.NET Core is equipped to handle both scenarios. With model binding, we commonly use the term inference to describe how ASP.NET Core is able to extract data from an incoming request. By using the API controller attribute on your controller classes, you're reducing the amount of work that you need to do model binding. Over the next couple of slides, we'll discuss the types of data that we can bind from and how to bind from them manually, just in case inference doesn't work to your benefit. While inferred by default with the API controller attribute, The from body attribute is used to tell your controller that you're expecting the body of a request to be used to populate an object. You will typically never need to use this attribute, but you might have situations where ASP.NET Core isn't able to infer what you want to bind from the body of a request. And just a quick side note, if for some reason you need XML support for model binding, you'll have to tell ASP.NET Core to inject that support. And that's easily done within your configure services method in startup.cs. But what's really cool is that ASP.NET Core will automatically decipher between XML and JSON for you automatically. You don't need to do anything special outside of this service configuration. After JSON and XML, the other common method for sending data to an API is via form URL encoding, or form data. ASP.NET Core will not infer this process by default. You're required to use the from form attribute within your actions in order to ensure the form encoded data is properly bounded. We've talked about in the past about the importance of the path of the request to designate the intent of a request. For something like a GET request, we cannot pass data via a request body or through form encoding. And query strings are a common mechanism for passing simple parameters into an API. The example here using page and page size is something we do in our systems. Another great technique here is to take advantage of C#'s default parameter values to ensure that parameters always have a value and that the value can be overridden by the incoming request. Every HTTP request and response being sent to and from your application will contain HTTP headers. Many of these are defaults provided by the client or generated by ASP.NET Core. But it's common in some applications to designate or override the headers of a request. You might have cases in your actions where the content of a header can dictate how an operation is supposed to work. The from header attribute allows you to bind parameters of your actions to the values of your headers if they exist in the request. In this demo, we're going to explore the new model binding processes we've learned about and see them in action. Before we start talking about model binding, I want to show you a pre-existing demo that we have that's already configured for model binding out of the box. Now, we've been using the products controller as a backdrop for a while now, and you'll probably recognize most of this code. The one thing I want to show off is that I'm decorating my controller with API controller. And we've mentioned this several times in the past, but API controller gives you a lot of flexibility and a lot of helpers out of the box. One of the most important ones is that it does some model binding for you automatically. So let's walk through a process. I'm going to set a breakpoint on line 36 of my create new product method. And this is an HTTP post, meaning I'm going to send data to it. And my expectation is that the product information that I send will get bound to a product object. I'll create that product object, get some sort of ID back from my product repository, wherever that is. And then I'll return a 201 created response code telling my client that I created the entity that it wanted me to create and where can it find more information about that particular entity. That's done with the created at action helper. And I know this might look a little cryptic, but let's walk through the points. Created at action will take, well, first, the name of the action that we can get the ID from. I'm using the name of keyword with C# to tell it, fill in the blank here with the name of the get product by ID method call. One of the nice things that this does underneath the scenes is that if I were to change the name of the method, get product by ID, I would have a compiler error that I'd have to fix. This wouldn't cause me any issues with things like magic strings. Now, because get product by ID takes an ID, I need to pass that ID into the created action helper. You can send in any object that you want to. I'm sending in an anonymous object, setting ID to whatever my created product ID is. And then finally, I'm going to send in the actual created product, because one of the things that we do with post requests is that we send back the new created object for the client to update any of its metadata. The created action helper will build the location header of the response, so it points to get product by ID. Now, however I format this route, now or in the future, created action will always ensure that the location has a valid URL inside of it. Well, let's walk through this process real fast with Postman and just show you what's happening. All right, I'm inside of Postman. I've already set up my post request to my API/products endpoint. I've added a body for a request that I want to send in, and I've made sure that the request type is set up as JSON. This way, ASP.NET Core knows that I'm sending a JSON request, and it should handle that appropriately. Let's hit send. We'll hit our breakpoint on the back end, and if I mouse over new product, we can see that it automatically filled in the blanks for everything that I was expecting: description, name, and price. Now notice ID wasn't in the request, because ID isn't something I want to give to my post request. It's something I should get back, because I don't know what the new ID is going to be. If I execute create product, that adds a new product to our data store and returns whatever that created product should be. And notice it set the ID for me. So now I can set the created action helper to go do its work. Back over in Postman, we'll see our response is the new object that got created. Notice it has an ID now. But if I also go to header, I can see the location header points to the get product by ID route for this particular product. And then lastly, it's returning a 201 created, meaning everything worked the way that it was supposed to. And real fast, just for fun, let's show you what happens if we were not using the API controller at the top of our controller. A little bit different. We'll run the application. We'll hit send again. But this time, my product doesn't contain any bounded data. It's null, 0, null, 0. And it just worked a moment ago. So what do I do in these cases where maybe I can't use API controller and I need to set up the binding for the JSON coming in to a product? This is where additional helpers come into play. I can tell ASP.NET Core that I want to bind this parameter from the body of a request. And this is what API controller does for us automatically underneath the scenes. We don't have to ask for it. But in the cases when you do, let's rerun this example. I'll hit send, take a look at our object, and it's set to the metadata that we were expecting. Now, no matter what your use case, from body will ensure that you're binding from the body of your request. Next, we want to take a look at possibly sending data not as the body of a request with JSON or XML. What if we want to send it as form data or form URL encoded data? And this is common with a couple different clients, just depending on what their needs are. So I've already set up a request here, name, description, and price to show what a product is. But I need to make some changes to my controller in order to support form input. Now, over in my product controller, because I can't use or assume from body now, I can add a decorator to the product called from form. This will read form data coming in from a request and see if it can make the same bindings to a product that we would with JSON or with XML. If we run this example again, everything should work. I will hit send. We've hit our breakpoint in the back, and now my product has product information in it. But this time it's pulling from form data instead of the body of a request. Likewise, if I send it as form URL encoded data, I should have the same result. My new product has data inside of it. Another common thing you'll want to bind from are going to be query string properties. And let's look at this use case. My get products action might need to take something in like page size or page number if I want to add a paging feature to it. How would I add that using query strings? Here is my initial request. It's a GET request to API/products. I'm going to add the question mark to designate query parameters. Now in Postman, you can add these directly as keys, but I'll write them out long form. I'm going to add one called page size. And I'm going to say the page size is going to be 50 initially. And I'm going to add another one called page number. And we'll start with page number 1. So I have two query parameters, page size and page number. Over in my controller, I need to tell getProducts how to handle the cases if and when these query parameters exist. Well, let's add the parameters first. So int page number, int page size. And for both of these, I'm going to set default values. So page number is equal to 1 if page number doesn't exist. And then page size, we'll set it to 25. How about that? Well, I still need to tell the controller to pull these values out of the query string if they exist. And that's done with the from query decorator, which I'll copy and use on page size as well. Now I've set a breakpoint on the first line of my action so we can see what's happening. And we'll hit send. This hits the breakpoint on my server. And we'll see page number is equal to 1, but it's equal to 1 in both places. Now page size, I have a default of 25, but my clients is sending 50. Let's see what the value is. The value is 50. So yay, I'm overriding the value based off of the query. Let's change our query string just a little bit. I want to take page size completely off. I'm not going to add it at all. We're going to tell it to use page 5 and hit send one more time. On our breakpoint, we can see page number is set to 5, so it's pulling that value directly from the query string. But then page size, we didn't pass at all. But because I have it set as a default value in my method signature, it's set to 25. Now this is a really good fallback, especially if query strings are not required. If for some reason you require a query string, don't set the default value. Do a model check when you execute this action, and if it's missing, return a 400, bad request, that your request did not match your expectations. For our last binding example, we're going to talk about headers. So you make a request, there are headers attached to the request into the server. You might expect certain headers to be certain values, or you'll want to check to see if those values exist. Well, we can do that with ASP.NET Core binding. I'm going to add a special header just called X header test, and we'll set this to no particular value. When I send this request, I want ASP.NET Core to extract the value of X header test and provide it to me within the method call. In our method signature, we're going to create a string. We'll just call it header test, but I'm going to decorate it with from header, tell it the name of the header that I care about. So now when I run this code, I'll hit send. My breakpoint will show me that the value of X header test is foobar. That's pulled out directly from the request. In this section, we're going to discuss model validation within ASP.NET Core and how you can use it to ensure your APIs are receiving the necessary information to perform their tasks. We've discussed the various mechanisms built into ASP.NET Core for receiving and binding data to objects that can be used within our actions. This process alone will save you a ton of time and give you the flexibility to concentrate on adding value to your project. But remember the rule of receiving data from a client. Never trust it. And that's where model validation techniques come into play. ASP.NET Core gives us a toolset to designate the rules for our models, and it will enforce those rules for us. We'll begin with a sample model. Your domain will determine what properties and requirements will be set on the model. In our example, our product doesn't have much. ID represents the unique identifier for the product instance in our database. Name is what the customers will see on the page. Price is how much the product costs. And description is a long-form overview of what the product is. If I were to create a new product via our API, what parts of the product are absolutely necessary to create it? The Data Annotations library of .NET Core gives us a variety of attributes to designate the rules of a model. Required is a common attribute. When model validation occurs, if the value of name is null or empty, the validation will fail. The same goes for description. But what about price? Even though we've marked it as required, price would still have a default value of 0 if no value was provided. Is there a better way to do validation? Is there a better validation technique for us to use? Of course. For price, if we want to ensure non-zero values, the range annotation allows us to state what valid values of a price would look like. Hopefully no one wants to sell a product for more than $10,000. Uh-oh. We just got a new requirement from the database team. They'd like us to restrict the length of a name to 25 characters. Can we set up our model validation to restrict new products with a string length of more than 25 characters? Absolutely. The string length annotation takes the maximum length of a string as a parameter, and it'll fail the validation if the string passed in is longer than 25 characters. Another thing to note here, annotations are stackable. Name will only be valid if it has a value that isn't null or whitespace, and if the string length is 25 characters or less. Do you remember our friend API controller? Turns out, when you have a controller set as an API controller, you get automatic 400 responses in the case where an incoming model fails validation. Now, what does this look like to the client? This example sends a name that's a bit longer than what our model can tolerate. Notice that it returns a 400 bad request and provides us with the exact issues the controller was having. These errors can be used by a client to give feedback to a user. If you're not using the API controller decorator, you can easily check the status of a model within the model state object. On any incoming data or model binding, ASP.NET Core will perform validation. All you need to do is check the isValid property of the model state to see if it's acceptable. In the case where the model state isn't valid, it will contain a list of properties that failed validation and why. This information can be passed to the bad request response method, but it's also useful for logging in application telemetry. And we could spend hours talking about the annotations that exist in ASP.NET Core by default. Check out the list of annotations at the URL at the bottom of the screen. Many of my favorites include required, data type, which enforces that the model data matches a particular data type, like date times. Email addresses and similar annotations ensure strings follow a particular format. And worst case scenario is you could use a regular expression. Do you have a validation idea that doesn't exist in the standard library? Write your own. Custom validations are simple to write and implement across your applications. In this demo, we'll walk through an example of adding model validation to an application. As we start talking about model validation, let's look at just a simple request. My controller is already set up, and I'm decorating with the API controller attribute. This means I get a couple freebies for any request that comes in. The first thing is that I get automatic model binding, which we've talked about in a previous demo. But I also get automatic model validation. So let's run through this example of creating a new product, and my product has no model validation set up on it. It's just ID, name, and description. And price. So if I go over to Postman, where I have a request already set up, I will hit send, and it will add my new product. So I have an ID, a name, description, and a price. Now, let's go ahead and add some validation rules to our object so we can ensure that when bad things are passed in, that weird issues don't occur. Let's start with an example of Twig, or the name of the product. If I accidentally set this to nothing, this shouldn't be a valid product. But if I hit send, it will be. It'll get created and added to a data store. Let's go back over to our code. I'm going to stop, and I'm going to add some data annotations to my product. The first one is required. I'll add this to name and description. And don't forget to add the using statements, component model data annotations. We'll save and hit F5. Back over in VS Code, I'm going to take the same request that I had before, no name, no description. I'm going to hit send. Well, because API controller does automatic model validation for us, it will return a good error telling me that there was an issue with the name property and that the name field is required. If I were to do the same thing for description, it would tell me the description field is required. On top of that, what if they were both empty? It would tell me that they were both required fields and that I should go back and fix my issues. But when everything is set correctly and I hit send, the item is added to my data store. Let's look at another type of annotation. For price, I might want to tell it to use a particular range. And this can take a variety of values, but I'm going to tell it needs to be at least 1 cent, or it can be up to $10,000, which if you're selling for something more than $10,000, awesome for you. But let's set some sort of range so that this comes back as an error if it's a 0. We'll go back in the Postman. I'm going to set price to 0, so nothing at all, and hit send. And this will send back a validation error telling me that price must be between 0.01 and 10,000. And there's a whole list of annotations that we can use. One other one that's a little bit more obscure is, what if I wanted to add an element to a product of contact email address? So maybe this product has a certain person or company that you should email in case of issues. Well, I want to make sure, that it doesn't need to be required, but I want to set it as an email address, meaning it's a name at a domain dot a top level domain. It should follow that general pattern. Well, let's rerun this. We'll go into our application. We'll set a price to something that's legitimate. We'll add contact email address. And we'll set it to something that's not valid. We'll just say Kevin. We'll hit send, and I get back a new error. Contact email address is not a valid email address. That's cool. That's what we'd like to see. Let's set this as something valid. And hit send. Everything goes through exactly like we expect. Now, all this has been happening automatically in our app because we use API controller. But what if that's not the case? Let's go into our product controller. I'm going to remove or comment out API controller. And now model validation will happen, but it won't return a 400 automatically. Let's set a breakpoint in our app. And I'm going to go back and change this contact email address to just be something invalid. And we know it's invalid, and we know ASP.NET Core knows it's invalid. But what happens inside of our action now? I'll hit send. It's going to hit my breakpoint. Automatic 400s did not happen. Now I'll look at the product. And the product's null because I also forgot about model binding. So let's add our model binding. We'll try again. All right, we hit our breakpoint. We'll look at our product and we'll see the value is there. So contact email address is set to just Kevin. This is not a valid model for our data. And ASP.NET Core knows that it's not valid. It's just not doing anything for us automatically. How do we ask ASP.NET Core if we have a valid model? Well, at the top of our controller action, I'm going to add just a simple if statement and ask it to check model state to say, is model state valid? I'm going to not this, so I'll get the inverse. So if model state is false, meaning it's not valid, I then want to return a bad request, and I'll pass in the model state automatically. This will make sure that we still get the fancy errors that we were expecting before. Now, important note, if you're using API controller, you don't have to do this step. You get it out of the box. But let's rerun this issue. And now I get contact email address field is not a valid email address. And notice it's also not giving you all the other metadata that goes along with an unhandled exception. It's just giving us the things that were bad about this request and returning the 400. In this module, we discussed data manipulation, model binding, and model validation. The goal overall being that we're able to take data from an incoming HTTP request, get it into a format that's useful to us as developers. The goal overall being that we're able to take data from an incoming HTTP request and get it into a format that's useful to us as developers. Model validation takes this binding a step further by ensuring the incoming data fits within the domain rules we've identified in our application. Remember, never trust the client. Validate everything. Thanks for listening to Creating, Updating, and Deleting Data from an API module, part of the Building APIs with ASP.NET Core course. My name is Kevin Griffin.